Hey there, intermediate algebra students. Coming to you live from my upstairs bedroom here on the Holland Street residence in Blue Earth. And I apologize, so my technology isn't working great, so you have to watch me write a little bit more than usual, but hopefully you'll be okay with that. Here's lesson 8.2 on substitution. Now again, when we talk about substitution here in algebra, we're not talking about a athletic substitution where somebody comes in place of somebody else, or a substitute teacher. That looks a little bit like me, I'm sorry to say. But we're talking about another method to solve a system of equations. This one is purely algebraic, so we won't need to do any graphing or anything like that. So let's get to our here right away. And so my system of equations now is going to be this. I'm going to have one of my equations will just be y equals 3, and another one is going to be 3x plus y equals 6. Again, this can be a system of equations because there is more than one equation. We're going to try to solve them both at the same time. If you remember last lesson, we did this all by graphing. And graphing is good, very visual, gives you a good idea what's going on. But sometimes graphing is kind of time consuming and it doesn't really work for every system of equations, especially if your solution or your intersection of those two graphs will be at some kind of strange coordinates. So we want to show you another one now called substitution. And with substitution, essentially what we're going to do is rewrite one equation so it just has one variable. So we're always looking for a single y or a single x that we can substitute. And sure enough, we have that in this case. What I'm going to do is I'm going to take this y equals 3 and I'm going to put it in place of this y right here. So I'm going to rewrite the bottom equation, but instead of writing 3x plus y, I'm now going to write 3x plus 3 because y equals 3. And then I'll see if I can solve this. Notice now I have an equation that has just an x in it, so I certainly should be able to solve this without too much trouble. I'm going to subtract 3 from each side. I'll get 3x equals 3. Simply divide both sides by 3, so x equals 1. Now remember, I'm not quite done because our solutions on these systems of equations are almost always ordered pairs. So I need to find my y value as well. But as you notice here, I have already got my y value. It's right up here. That was part of what was given to me here. So I can right away now say that my final solution is going to be the ordered pair 1, 3. Remember, x is my first coordinate and y is my second coordinate there. So that's a real basic example of substitution. So now let's get to challenge you guys a little bit more. Alright, so let's take a look at this one. So we're going to have 2x minus 3y equals negative 2. And my second one is going to be 4x plus y equals 24. This one's more complicated looking, of course. Both of the equations are in standard form. Makes it a little bit more messy. And so you can see I have a few different routes I can go, but as I mentioned before, the good strategy is I'm always looking for a single y or a single x. I'd like to solve for this guy right here. So I think you see that if I subtracted 4x from each side, that y would be negative 4x plus 24. And here's where my substitution comes into play now. I'm going to substitute this y value here now that I figured out in place of this y value right there. So I'm going to rewrite that green equation. I'll make it green here now so you can see this. So I have 2x minus 3, but now instead of writing y, I'm going to put in that expression that y equals negative 4x plus 24. And then I still have to finish out that equation. It's still going to equal negative 2. Now this is a bit of a mess, but at least you can see now that I have just one variable in this equation, so I should be able to solve it for x. Let's see what I get. So 2x, have to do a little distributive property here, so negative 3 times negative 4x is plus 12x. Watch out for that sneakiness. And negative 3 times 24 will be negative 72, I believe, big numbers here, equals negative 2. I can combine some stuff on this side. 14x minus 72 equals negative 2. Next I'll add 72 to each side. Running out of room here. So I get 14x equals 70. I'm going to divide both sides by 14, and actually then I get that x equals 5. So that's half of my answer, remember. And so now I have to figure out what the other part is. I'm going to probably go back to maybe this orange equation up here, and I'm going to rewrite that, but I can put this 5 now in place of that x. So in a sense now I'm going to substitute this 5 in place of this x right here. So 4 times 5 is 20. I'll write up here since I don't have too much room. 20 plus y equals 24. I'll subtract 20 from each side, and sure enough I'll get that y equals 4. So my final highfalutin answer here is the ordered pair 5 for the x and 4 for the y. So that's a little bit messier, and that's why some kids don't like the substitution method, because it is pretty heavy-duty algebra. It's easy to make some mistakes unless you really work carefully with this. But it is a good method. You can always get an exact answer, and it allows you to not solve by graphing. All right, here. And again, this is a bit of a strange one per se, but let's just see what it looks like. So here's my next system. Y equals negative 1/3 x plus 2. That's one of my equations. And my second one is going to be x plus 3y equals 6. Alright, remember we said look for your single y or single x, and we have a couple choices here. Actually, we already have what y is equal to. So as long as we have that, I'm tempted to say our best bet is to put this right away in place of this y. So I'm going to rewrite the bottom yellow equation here. I'll get my yellow color going here. So I'm going to have x plus 3, but instead of y I'm going to put in negative 1/3 x plus 2. Again, that's still got to equal 6. So then I do my little distributive property here again. So 3 times negative 1/3 should be negative x, and 3 times 2 of course is 6. I still have this x here, and look what happens here. X minus x, those cancel out of course, 1x minus 1x, and look what I have left with. 6 equals 6. So what in the world does that mean? That's a little perplexing perhaps. My variable dropped out, so I can't figure out what another y value is. But as some of you might have figured out, these are actually, each of these equations represents the same line. The same line. It's just that this one is in slope-intercept form, this one's in standard form. So what would we say about the solutions for the same line? Well, we would say then that there are an infinite number of solutions, and that's what we'd say for the for our solutions. And the word we're kind of learning about here is that these lines then are coinciding. Coinciding. That means they're the same line. They look different at first because they're in different forms, but when we really get down to it, they are exactly the same line. And when that happens, you'll get some weird looking stuff like this. Now, what do you think would happen if we used the substitution method and we had parallel lines? Well, once again, the variables would drop out eventually. You'd get two numbers equal to one another, but the two numbers would not be the same. they would be two different numbers. So if you get the same numbers like this, we know for sure we have an infinite number of solutions, coinciding lines. If you get two numbers that your equation says are equal to each other, but they're two different numbers, then you know that can't be, and that would be a case that there are parallel lines and thus no solutions. All right, thanks for hanging in there during this lesson, and we'll work on substitution tomorrow. Kind of tricky stuff, but I'm confident you guys will be able to get it. All right, thanks for listening. We'll see you guys in class.